Welcome back to Cruder.com. In this next financial formulas video, we're going to continue going over the time value of money formulas, specifically the future value formula. I've gone ahead and set up this investment example here to go ahead and figure out how much money am I going to have when I'm going to be retiring. And currently this example shows that we're going to have $816,000 when we retire. And it's all based on these inputs up here. So let's start here first. Let's pretend that I currently have $100,000 in my bank account, and that's the amount of money that I want to start investing. So I sign up with a brokerage firm and I give them the $100,000 to invest. They then tell me that they on average are able to return me 9% on my money each year. And then I say to myself, well, how many years do I need until I'm ready to retire? And so I've said that in 20 years, I'm going to probably be ready to retire. And then lastly, I need to ask myself, is there any additional amount of money that I want to invest each year to continue to grow my investment account? And so I've put in another $5,000. And notice that both of these numbers are negative, which signifies that it's outgoing money. So let's go ahead and see how this future value formula is working. Let me pop into it with F2, and you can see that the first thing it needs is the rate. So the rate I've put in as 9%, and then the number of periods, which is 20. And then the payment, I'm putting in $5,000 extra each year. And then the present value, it says it's optional because you don't necessarily need a present value. It could be 0. But in this case we do, and I have $100,000 plugged in there. Let me return it, and $816,000 is created. So how much money do we put in to begin with? Well, we put in $200,000, and that's found by saying we put in the initial $100,000. Then for 20 years, we put in an additional $5,000 each year. 5 times 20 is 100. Add the zeros, that's another $100,000. So $200,000 total. Therefore, the total paid in less the future value is our capital gain of $616,000 over 20 years. This is the growth of the investment. So this is a perfect example of when a future value formula is needed. But most of the time when we're going ahead and thinking about investments and retiring, we're usually thinking, all right, I know that in 20 years from now, I'm going to want to have a retirement account worth $2 million. So in that case, the future value is known. We want to have $2 million here, but we don't know how to get there. And so I've set up this other example on this next tab. So let's first go ahead and focus on this part right now. And as you can see, all of these inputs are the exact same. So my initial investment is $100,000. I've hard coded in here my future value of my investment that I want to have $816,000 when I retire. So this is now an input instead of a calculation. The rate is still 9%. I want to retire in 20 years. Then the payment is even the same. So I'm going to make a yearly payment of $5,000 to be able to have $816,000 in 20 years from today. Now I've switched up the calculation from the future value of the investment to the payment. How much do I have to pay yearly into the investment to therefore be able to have $816,000 in 20 years from today? So again, usually you're thinking, I want to have $2 million in my investment account when I retire, versus saying I only have $5,000 extra per year to put in. How much will that get me in 20 years from today? So therefore, for me to be able to have $2 million in 20 years from today, I'm going to need to invest $100,000 today, plus I'm going to need to invest an extra $28,000 per year. My total invested capital will be $662,000 cash, but I'm actually going to have a capital gain of $1.3 million. This is the growth of the investment account. So one thing I want you to notice is how I've set this up in a template-like format. And I've highlighted the cells that are editable, and then the other cells that are not are calculations. And then lastly, I want to go ahead and point out that I've added this table here that goes ahead and looks at the investment value each year. So it says the first year I'm going to have $137,000 because I've invested $100 plus the additional $28 at the end of the year, and then plus that first year's interest gets me to $137,000, and then I've just copied this formula down. So all I've done is said, all right, the future value of the rate, which is 9%, the periods, which is right here, the first year, and then the payment of what I've calculated above, and then the present value, which is my initial investment of $100,000. So I'm able to just drag this formula down to get the rest of these values for the next 20 years. And one thing I noticed that I want to point out to those of you who are not financial experts is that the curve on this investment timeline is very subtle. So then when I went ahead and I extended this table down to year let's say we're going to put it down to 50 years. If we could save up and invest this over 50 years, you can see it gets to $30 million. Now, look at the steepness of this curve now and how big of a curve it is. It's no longer a subtle curve, it's actually a very sharp curve.